This is part 2 of section R.8, nth roots and rational exponents. We're finishing example 2, starting with part D. Now we have a cube root problem. So let's think of the perfect cubes. These are all variables. So x to the first cubed would be x cubed. And x to the second cubed would be x to the sixth. And x to the third cubed would be x to the ninth, and we see a pattern here. For perfect cubes, they're all multiples of 3. For perfect squares, we saw all multiples of 2 are all even numbers. For perfect cubes, all multiples of 3. So we want the highest multiple of 3 in each one of these. Notice that x squared, the 2 is less than the 3. That's not coming out. There's no x to the third. Our lowest possible is x to the third. So that one will stay. But we have the cube root then of x squared, y cubed times y, and the highest multiple of 3 in z to the 10th would be z to the 9th. Z to the 9th, but we have an extra z. Okay, so we said the x squared will stay. We'll take the cube root of y cubed and get y. This y will stay. We'll take the cube root of z to the 9th and get z cubed. And this last z will stay. So we have the cube root of x squared, y, and z, with y times z cubed on the outside. Okay? In the next one, notice what we have. We have multiplication. We saw that up here. We saw we could break it apart, but we can also pull things back together. So we have numbers in this one, so let's think of our perfect cubes when it comes to just integers. So of course 1 cubed is 1, but 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. So none of these, 9 or 3, neither one of those are perfect cubes. But I wonder if we multiply these. This says we can multiply. Let's do that. So we have 2 times the cube root of 9 times 3 times, and then the 2x squares. We can bring it all together. So that equals 2 times the cube root of 27, and when we multiply these, we add those exponents, x to the 4th. And look what we found. 27 is one of our perfect cubes. The cube root of 27 is 3. So we have, taking the cube root of 27, we have 3. And then let's just write what's left so we can make sure we understand what happens here. Then we've got to find our perfect cube in x to the 4th. Of course, that's x cubed and an x. There's our 4 x's. So 2 times 3 is 6. We take the cube root of x, we get x. And then we have the cube root of x left. That one x stays behind. We had an x to the 4th, and one of them stays behind. Okay, in our last one, what we have is 9 plus the square root of 18 over 3, and the square root of 18, we need to simplify that radical. We're looking for a perfect square factor, the largest one. So we look back at our perfect squares, and the largest one that's a factor of 18 would be 9. So we have 9 plus the square root of 9 times 2 all over 3, which equals 9 plus, what's the square root of 9? That's 3. Square root of 2 all over 3. And now I'm seeing that if I can factor out a common factor in the numerator, I can cancel it with the denominator. So I see a 3 in both the 9, so I'm going to write it like this, and in the 3 square root of 2. In other words, distribute, I have this. This is all over 3, and now I see those 3's cancel, so my final answer is 3 plus the square root of 2. So we simplified that radical.